So really, what's a sensor? How do you actually transform properties? One of the easiest ways I can think about is like a resistor. A resistor is usually just like a wire, like traditional resistors are just like wires like wound in a coil, or maybe they do it using carbon film and all that. But what it does is pretty much it has like an area and it has a length. And the resistance is proportional to the length. That means the longer it is, the more resistance current will have. And the bigger the area, the less resistance it would have, just like water going through a pipe. And so once you heat your wire, what happens is, based on the temperature, it can either expand or contract. So when I heat it, it becomes bigger. The cross-sectional area increases. So since the resistance is proportional to length of area, pretty much I can use my temperature to change the area, which changes the resistance. So pretty much if I put this, like say, in a circuit, I can use like Ohm's law. And because voltage is equal to my current by my resistance, pretty much I can change my voltage or I can change my currents based on my resistance changes, which is based on my temperature changes. So it's easy. It's really easy to take like physical properties just by understanding materials and how things work in nature and very easily translate them into electrical signals. And then we can translate those easily into digital signals. And so I'll then put those like in a potential divider circuit, and my sensor, like my wires wound, are really what's like R2, which is pretty much a resistor that changes value based on its temperature. And then I can put that in a voltage divider using a pull-up resistor. And so it's really easy to take that and put it in a micro, change it into digital signals through the analog to digital converter, and pretty much calibrate it and get my data get my temperature being in a form that I can transmit it anywhere in the whole world and maybe even respond to it. So if I take like my grow bed, so back to my tank, back to my table and back to my model, I can then add sensors. For instance, I can put a sensor in my tank, and that would probably just be like a magnet that's floating with click, with maybe like contacts that click. So as the water rises, pretty much I can change that physical property into electrical property. And then like I can put like sensors that see if my water is flowing. If my grow bed is full, like I use like an infrared sensor for that I just bounce on the water. And so there's all these sensors I can put. And really my first level of sensors is trying to make sure that I can get my water cycle going correctly, because I'm trying to make sure that I get my water cycle going, because if I can't simulate what the sun, how the sun works with the earth and the water, so that's pretty much what I'm trying to do. So I can get all these sensors, and pretty much once I get the sensors that I need, and those are like typical sensors, I can then, there's things I can control, and things I can control, say in a garden, I like the grow bed, my water pumps, my reservoir, so that I can refill my water automatically. I can control like in my case, like a fish feeder, and the things that I pretty need to make sure that my model, so that the important points in my model are disconnected from me as a human as much as possible, but I can still get the important things going. So I then take my model, pretty much take my garden, put it into an 80 mega chip, and put those through a Linux, and through a Linux computer, and pretty much just like shoot them out. So what I would have is, in my case, from very early on a really low level, I start using JSON as my data exchange. And so it becomes really easy for me to build on other tools that are out there already for data processing and even on the internet. And it's also a really light data format exchange. And it's compatible to many databases and many applications out there. And it becomes also really easy. Like, for instance, if I decide like I want to get like more properties on a sensor, I don't have to change a lot, because I can just add those properties as fields within my JSON string. You know, if I need to pad more information that will maybe allow me to calibrate things over time, or just anything, or even to add new sensors, it becomes really easy. So I use JSON like really early, and then also on the internet, I can allow me to do like sockets and pretty much. So again, the whole idea is like, how do I come from something physical, and what's the easiest way for me to go into data so that I don't really deal with physical things, but I get all the data that I need that represent my physical stuff. So that's like a typical like controller I used the first time. So the first side is like an 80 mega chip that I built that can take like the sensors. The second part is like a Linux computer, pretty much hacked like a small internet router, TP-Link, the small blue ones that cost $20. And so I can get like a powerful computer. To me, that actually does more than a Raspberry Pi or even any of the Arduinos, because it comes with Wi-Fi. It comes with a bunch of USB. I can run Linux. I can do a lot of things I would not be able to do with a lot of micros. And it also has like a lot of I/O where I can connect like analog sensors and digital sensors. So over time, the route I started on the first, that's a SS router, was the first Linux router that I used. And then I went to the TP-Link, and the ones on the far side are the ones that I'm using now. They're actually like small Linux on a chip computer things that I'm using pretty much for my controller. And this is like an example of like my new board, one of the boards that I use. So pretty much I take like the small Linux thing and I hook it up with a 256 Arduino. And so I get like, not Arduino, but 80 mega chip. So I get like all the I/O I need, all the serial ports I need, the USB, and pretty much I get like a really flexible computer that can run, that's Arduino compatible, but will also still run all the Linux code. But the best part about it is I don't need like all the shields, because a lot of things that I would normally put up as a shield or a cap actually built in. Like I have like transistors that can build in, but I don't talk much about this anyway. So what I do is I take the garden, take my controller, shoot it out using Wi-Fi or whatever internet connection exists onto the internet into the database. So again, because I'm using JSON, it becomes really easy. Like I can use things like Mongo. So if I ever change like sensors in the field, I don't even have to worry about my database schema, because like when I used to use like using things like Oracle or MySQL means like anytime you have to change anything in the field, like, oh, you know what, I don't like this sense, I'm going to put one in any controller, means like going back into your backend and trying to change like your database just to adapt that. So JSON really works really well, and being able to use like a no SQL and flat schema type databases also works really well. And especially since you can imagine like as you get more and more these devices sending like data streams like every couple of seconds, just how much data you have. So it becomes really easy for just, in my opinion, managing data like this. So, and then I use on the other side pretty much can access the data using APIs and stuff like that. So you're not even directly talking to your garden. You can if you want to, but then pretty much you talk through a database application that you pretty much. So the whole idea is like you're not controlling things directly, but everything is data-driven, because pretty much you put stuff on a database and then your garden checks and then it responds based on that. So that way I make sure I keep track of every operation or everything that happens, everything pretty much that instructs the garden and everything that the garden responds to. So those are pretty much some advantages of that. So I use an API, it becomes really easy. So you just give it your unique name at the last part, the last part of the string, and pretty much you get your JSON back with whatever data. So the thing is, the 80 mega side is like really generic, and then all the custom data pretty much gets added by the Linux part. So by the time I'm done, I can build like really composite data structures that allow me to transmit data really easily and access it really easily from a physical end and a digital end. So with the API, you can tell it like this would be the latest data stream by default, or you can tell it like, give me the last 10 records, last 100 records, give me data between this time and this time. Give me data that had errors, so it becomes really easy for anybody or any other third-party application to actually interact with the system using any other tools. And then it becomes nice because all you need to know is JavaScript. And even if you don't know anything about electronics or backends, you can actually interact with the data and still do a lot of stuff with it. Yeah. So after this, the next thing is pretty much visualizing data. It's 4:20. I was supposed to stop for a 10-minute break, or I can continue. Continue? I don't know why they put a break at 4:20. This is Auckland. Maybe you guys really need it. Yeah?
Can I ask a question?
Yes, sir.
I'm curious about the animal component. So you mentioned in passing, though it wasn't in your illustration, that you have to feed the fish. You also have to buy the fish, right? Because this isn't an existing pond somewhere in nature that exists where most aquaponics systems are introduced, right? Something already exists. It's a system that you're getting a side effect from. But you're creating this from scratch. So at least from energy or money, how efficient is the system if you have to buy fish, feed fish, breed fish, keep the pumps running? Do you have a net gain in this system?
One, I really don't know anything I don't have to pay for. So I don't measure efficiency in terms of how I spend money. And then two, it really depends on what you're doing with your garden. Is it for you? Is it for commercial use? Is it for educational use? Whatever it is, automation will make it easier. Okay.
Do you live off of your garden? Do you have a system that you...
I eat a lot of my gardens. I do. They make a big, they supplement my meals a lot, but it's more than that. It's that I smile for no reason sometimes. That's actually like worth a lot of other things. And if you want, I can talk more about a garden part later, and schematics and the business and all that. But the truth is, if you want to get there, it's like farming is one of those things where pretty much you don't make money. I've never seen, I know very few rich farmers that didn't do alternative crops. So to me, it doesn't matter how easy your growing system is. You're pretty much in a losing field. You see what I mean? All you can do is just make yours better. But when it comes to business, it's got nothing to do with what you're doing. It's really how you sell it. Remember McDonald's? They don't make the best food, but they sell it every day. So I just feel like business money stuff is different from technology and growing food and all that. Yeah? I try to focus on smart aquaponics for now, and then we can talk about that later. So the thing with IoT and visualization of data is your data is really different. You have different data forms because they're coming like from sensors. Like that one garden I showed you, I was just showing 8 sensors. But some of those sensors have like, say, a value of 100. And some of them have a value of 1, like a logic 1. You know, like temperature goes to 100 degrees Celsius. You know, things where I'm calibrating based on percentages go up to 100. Things like flow rate for my pump might be at 2 gallons per minute. You know, so some things at very small values, some at really high values. How do you show all your information without like losing some? Because in an attempt to make your graphs fit everything, pretty much you lose like resolution, you lose like precision and stuff like that. So you can actually get scales that look well. So to me, I feel like being able to keep all your data is the basis of a lot of things. So my process for learning and actually for dealing with data is I collect it fast, and that's where the sensors and all the controllers and being able to transmit it comes in. The next thing is pretty much like, in my case, I really don't have like a background in aquaponics. I didn't go like to college in aquaponics, and even a lot of things I've met in my life, I pretty much didn't know about them, but I had to learn about them, especially professionally, especially things that involve like collecting data and interacting with it and doing new stuff. So visualization allows me like to get like a lot of intelligence from my data because I can present it differently, and I may see things I would not normally see. And so that's subjective. And then after that, I can pretty much turn that into knowledge. Maybe I can put it in a program and put it in a chip because now I'm sure if I put it, your garden's going to work that way. And then later on, you know, it can be wisdom. I can tell you like, hey, you know what, you're doing it wrong because this is how it is. So the next stage in this for me is like pretty much learning out of the data. And it all depends on, it allows me to look at the data differently. So one of the visualizations I use a lot, I like what I call like process control animations. So I draw diagrams that look like my process, and then I can change colors. So I can easily tell like, okay, my water is flowing because my pipes are blue. I can tell like the level of my water. I can tell things like that. It's not beautiful because I'm really not an artist, but that's processing. If you give that to a good artist, my water drops can easily turn into particles and look like they're flowing like a game. But I can pretty much draw my sensors just like I collected them and actually get them so they look like a picture. So I can tell like this one instantly, my pump was not flowing, my tank is full, my water is draining. So if I'm driving, I can just look at a picture and tell what's going on instantly. The other way I like to visualize, so this for me is like for instant data, but sometimes I want to like trend my data and look at it with respect like to time. So one of the tools I like to use are like horizon graphs. Horizon graphs pretty much take, like said, this was a line graph. I can then add colors to it for perception so that like the bigger the value, the more intense the color. And then pretty much I can take like my negatives and flip them over so that everything stays on the same side. And then I can pretty much take my different colors and collapse my bands. And that allows me to look at my same data, but differently. It looks a little bit weird, but see what happens when I'm looking at a lot of data. So I might not care about the details, but I can tell where the patterns are. I can tell like, okay, you had a lot of this here, this was increasing, this was not increasing. And it allows me to look at my gardens in a way that allows me to visualize all my data without hiding anything, because pretty much things that have bigger values just become darker. The higher the values, the darker it is, the lower they are, the brighter it is. So I really don't care about the details. So instead of looking at my pump or my tank or my light, I can now look at my garden in parallel because I'm seeing all the things at the same time. So rather than dealing with the detail, I can actually deal with how the different things relate. I can start talking about relationships, which allow me to generalize things more. And so I can actually use my data analysis processes to actually like standardize more processes and actually get patterns out of them. So what you're looking at there is like the one on top completely. That's like my grow bed rising. Every time it fills with water, you get those like little bumps going up and down. The second one is like my floret and just things like that. It looks a little weird, but once you get used to looking at it, it's actually really easy for seeing things that change. So for instance, a lot of people talk about grow beds like flooding and draining, like it's a one-way process, like, you know what, how it fills with water and then the water drain. But the truth is, it's actually a process with 8 different points. So like 1, when my pump starts, 2 causes water to pass through a pipe, 3 causes like the grow bed to fill, and then 4 causes like the grow bed to fill. So what most people see as one operation is actually like a bunch of 8 different things that depend on one another, and any one of them can fail, and any one of them can affect another one, and any one of these can be optimized to actually get better. So I wouldn't know this if I didn't break down my data this way, but now I can see how one thing affects the other one. So I'm like, okay, these things are actually interconnected. I didn't even know that, you know? So just by looking at my garden differently, I can actually start, I might not know a lot about farming, but by looking at that, I can start like seeing things I would not normally see, especially as I see more and more of it. So like, for instance, at the bottom, so you can see on top, everything was looking okay. And then at the bottom, suddenly I got a leak. So you see like where there's an arrow, and then the system shuts down. If you notice, like everything after that, sort of like the graphs start quieting. And so that's like how my system would respond to a leak normally. I wait for water to fall off the ground. I detect there's a leak, and I shut down everything. But when I started looking at this, somewhere, so the first 2 bumps, like the one with the dotted arrow, that's where everything is okay. Like where it's flat, that's pretty much like where it's the top of my garden, and that's like a normal garden working okay for that. And that's the grow bed I'm looking at. But then you notice the next one where the leak is. I actually noticed like before I even got the leak, something started changing, like the bump actually went higher. And so I realized, you know what, I'm catching my leak too late. I shouldn't really be catching it off the ground, because if I was looking at all my data while in parallel, I can actually see the leak happening before it even happens, because there are all these things that have to happen to cause a leak. So by being able to do that, I've actually optimized my leak detection, because now I can actually like use algorithm to figure leaks before they come. And I would not have done that. I would not have known this if I was not visualizing my data that way. And it's the difference between people buying a garden and putting them like in a really the best location in the house, and suddenly you leak on their nice Persian carpet. It's the difference between water spilling like somewhere and somebody like stepping on it and like falling and breaking their neck. So it's a small thing, but it's can easily be a small big thing. You see what I mean? But without being able to visualize my physical environment and actually be able to see it in parallel, I wouldn't have really realized what causes a leak. Because to me, a leak is what on the floor, but there's actually all these things that happen before leaks can happen. So I would not catch that without being able to visualize my physical data. And so I can catch things like, so I've been able to catch things to do the operational. This was a funny problem. For instance, every time I turned off my light, so the one in the middle, you can see like where it goes like half green, half that. It's supposed to be like all, my light's pretty much supposed to shut down, but my lights are not shutting down. It always killed me because when I looked remotely, my lights were off, but when I looked with my video, because the thing can also support video, my lights were actually off. And eventually I discovered it was the LEDs on the box were too bright that were affecting my light sensors, but it took me like almost a year to figure that out. So I was able to redesign my circuits just again by collecting my data from the gardens. I was able to like, you know what, you can actually make this a little better. So I've been able to get things that allowed me to change how I even design things like my cases. This was a bug where when the controller is servicing interrupts, it doesn't listen to commands coming through the serial line. And so I kept missing these commands, and then I eventually found it by that. So the first one is pretty much the system does not add enough water when it needs water. But then the second one is like, because it misses that command of like, hey, give me water, I need water. The second one at the bottom is like where it starts adding water. But then when I tell it, hey, stop adding water, it doesn't stop because it missed that command, because it was doing something else. So it really, and that happened actually in a school. For the longest while, I had a garden in a school and the water kept leaking in the floor and I couldn't figure what it was. But then as I started going through the data a lot, I started like realizing, oh, this is what, and tracing it backward, I realized it was actually a hardware issue. So I was able to change how my code works with it again. So a simple software problem and all that ended up affecting but physical thing. But my thing is with data, you can learn. So another example, I got through a couple of examples. This is like my pump failing. You can see how the bumps, there's like it's dark, and then suddenly it's not dark. So I can easily pick up when my pump is failing because the flow rate starts going off. And a lot of that is because the pumps start building like cholesterol on the inside in the tubing, and you really can't tell. So if I was looking with my eyes, I'll always say my pump is working okay, because I can't tell my water is actually reducing, but it progressively goes reducing. But that's not the problem. The problem is like when I look at the gradient of the slopes that actually control the garden, I actually realize I'm affecting, the consequence of that is actually much bigger than just my pump failing, because it means like I don't have enough oxygen in my system, so my fish might start dying or something might start happening, but I would not have caught that, again, if I didn't have sensors that could actually visualize my data in parallel, that I can see that, okay, this pump failing is affecting this, and because of this, this is getting affected, and because of this, this is getting affected. So what happens when you change your temperature? I never realized when you changed your temperature that you actually shock your system so much. So just again, normal operation that everybody does ends up actually causing like a lot of shock on your system. So that means if I keep getting, now I can tell like people changing their water without even looking at the water changes, because I can see how the system shocks every time that happens. And then the little pulses at the bottom are pretty much like the automation, like trying to stabilize it after big water change. So it's like, okay, just like small bursts, and then like, okay, now you're okay. And then it all goes green. And I like this one, sort of anyway. I didn't document it a lot because I got this from my friend's house, and I felt embarrassed even looking at it. I shouldn't be looking at people's data. My reason is everybody thinks of insecurity and IoT, and they think of like weak routers and weak applications getting actually hacked, which is a true concern. And that's one of the reasons I use Linux, because pretty much from very early on, I have like a system that has like a good security model, apart from when you get like the more normal Linux bugs that affect everybody. But these are actually 3 graphs, and the first one I can actually tell. In fact, the way I saved it, that file, I call it like a good evening, Drew, because this is from my friend Drew's house, and I can actually see like the evening kicking in, and then I can actually see them coming in, and I can see them going to bed, and I can see them waking up later, and I can see the next morning. So this information just from a little garden that has like a couple of sensors, this is just like a small garden is testing, I can actually like tell a lot about their habits in their house just by inferring and just by just looking at patterns I would normally not catch. But then suddenly all these patterns start showing up. So just by looking at sensors, I can tell when people come home. I can tell when people go out, when people, yeah. So I feel like your data that's also good to you can also bring like a lot of insecurity, because now you're reporting on physical things that are actually happening in places. It may or may not mean anything. When I'm done these, I'm actually planning like to give some to stores and actually give them like demo units, but I won't even have any flyers or anything. The whole idea is like as people interact with the system, I'll actually collect data and I can tell what people want to use more. But even better, I'll be able to tell how many people go to the store, what time they open, what time they go for lunch, what time, do people come in the evening, do they come, so I feel like I get a lot of things that can easily bring a lot of insecurity. So I have to make sure that the system can even, like, just from very early start building security models that prevent even people from getting the data. But the other side of this is, when I started this, I was thinking about gardens. I never thought I'd be getting this kind of data, because now I'm suddenly realizing that I'm actually getting data on lifestyles. I can actually collect data on how people live. So there's a lot of implications to that for me. It means I can actually use, like in this case, like a garden or a system like this to actually make people's lives better. For instance, this could be my grandpa. I could easily give him a garden that has extra sensors. In addition to feeding me, I can tell, is he taking his medicine? Is he going to sleep? What time is, did he even take a shower? Really easily, because I already have like the data stream built on, I already have the data analysis, I already have the alerting, I have the different visualizations. So it becomes really easy to grow. It means I can take the system and very easily customize it for people who are like physically challenged. People who've never been able to grow food. I can easily integrate the garden so that somebody that's blind, somebody that's on a wheelchair all the time can actually like grow their own food. And in addition, the garden can actually do like a lot of like home automation tasks for them, like make sure like closing the doors, shutting down the windows, just doing things we take for granted. So I can actually, I can take it and put it in a house, and it can start like managing my power, easily interacting with my solar panels, so that instead of getting my information at the end of the month, and then like I can modify my behavior based on my power energy readings, I can actually get an alert when there's a problem or when it's better. So if I got to do like my laundry and maybe like dry my clothes, now I can get a tweet message that tells me like, hey, dude, if you wait for 5 minutes, the sun is going to start showing up, and you can actually use like this of solar energy instead of using regular. So I can get like more instant information as compared to, because I'm connected with the physical world directly with the computer that's on my pocket all the time, and I can share all that. So these are sort of examples of ways I think like turning physical things into data can allow you like understand the environment better, and also as you learn more about data, you actually learn more and more about other things. So with internal sensors, I said those internal circles, a lot of that what I was going was pretty much just trying to simulate the outer water cycle. There's also like a bunch of inner stuff, so I can visualize again and look at a lot of my data, so I can also play around like with chemical readings and all that, and it's really easy to, but this is sort of, I like this one. So this is also one of my favorite sensors, which is time lapse. If you look at the fish, they keep moving, and one time they're in a different position. You see like they're going to make that shape. Did you see it? Almost like a hockey stick, and then it disappears. And then I really don't know what's going on, but every couple of seconds, I actually have data from my sensors. So I can then look at my visual data and later on compare it with my sensor data and actually start like saying, what does this mean? So I never knew I'd be trying to compile like my video data with my sensor data, so I suddenly realized it. I start seeing more stuff. So an example of that is, there's a time when you look at those time lapses, they seem to create like a graph. And I would only caught that through looking at those time lapses over and over, and it just comes for very little brief while I get that shape. So the fish actually visualize themselves for me. Just by looking at them, I can actually tell problems that are happening. But the thing is, how do I quantify some of that, and how do I start making sense of it more and more? So what's happening here is at the top of the graph is where my water is actually dropping down. And so because it's dropping there, that's where there's the most oxygen, I think, because that's where the bubbles are. Because the oxygenation of the system is just part of the water cycle going around. So because water is falling there, this only happens at a certain time of the day when the temperature is a certain value, when I have a certain amount of fish, and my plants are almost look like a certain way. And so pretty much what I ended up recreating without knowing and catching was actually like the same problem that results to a lot of like a fish kill in the world. People wake up in the morning and suddenly all the fish are dead in the ocean. So it's because, and it happens like about 3 in the morning, and it's because at night your plants pretty much stop doing photosynthesis. So instead of creating oxygen, they start using oxygen. And at that time, I have my fish also using oxygen. It only happens when temperature's a certain amount, because at that time, that's when the water has like, as it gets warmer, you actually have like less dissolved oxygen in the water. And it only happens when my plants are a certain size, because at that time, that's when they're using more oxygen. And it only happens when my garden is at a certain level, at a certain edge, because that's when I have the biggest biological load. So I was able to recreate a problem that happens in nature without even knowing. That's why during summer, all the fish die. And so as I looked at it more and more and actually started catching it, it became more and more consistent that I can actually catch these patterns by looking at them under certain conditions. And so I was able to recreate my software really quickly, so that when this happens, I just pretty much just make my pumps like pump faster and do that. So once I figured what the problem was, it was very easy like to change. But what I discovered there is also a problem that happens in nature. And my whole idea is like the sensors are so expensive, and the truth is like most of the times when I look at things, I don't need to put my finger to tell if the water is hot or if it's cold. I can just tell. I can tell you're about to die or something like that. So my whole thing is like, I think there's more power in visual in a camera as a sensor. It just needs to, and especially as a lot of ways of like analyzing pixels and things like that come in, it becomes really easy to just use a camera as your sensor as you build more and more algorithms. And the advantage of that is later on I can get like satellite shots of like rivers and oceans and lakes, and actually be able to apply like our algorithms out of things that I discover in people's houses and schools, and actually just be able to take the pictures and see like, okay, you guys are going to have like this condition really quickly because we've seen this over and over again. This is what this means. So a lot of the stuff that you're actually learning here is the data makes more and more sense, because it all started from you mimicking and modeling nature, ends up being able, you actually recreating data that you can go back and use for nature. So sort of I had some live links, but I'm not even connected, so I won't even bother. And anytime I try like to connect things and do like a live demo, nothing ever works. And that's sort of me. So I feel like the future of this is pretty much, I know, I just feel like my world changes when I can perceive it in data as compared to when it's just like a physical world. And this is just one example, so, and it's just a garden, but then the sensors can be on anything, can be on any application. But my point is data is a useful thing, and I feel it's really what IoT is supposed to be, as compared to just turning things on and off. Because to me what you're doing is you're simulating people, you're modeling against people. You're not just showing like, hey, I can turn this on and off, hey, I can do this. It's more like, how do you start, you're trying to fly, you study birds. get the best way to fly. Trying to crawl walls, you study roaches. So it's sort of like, what's your problem? Are you just like throwing technology because there's technology? Or you're really just trying to use technology to actually solve like human problems? So that's an example of how you can use technology to grow better food and understand the nature better. I think I'll take questions if there's any.
Cool. Is anybody using this like industrially or academically?
Not at this level that I know, and those that I know are stuck in hardware land, just trying to turn things on and off. I think it's a bigger problem. So the thing is, I'm hoping, I mean, I have like some, I don't know what you mean by commercial. It's always a weird one, because I do have like, I use the same thing for tanks that are 2 gallons. My default size tank is a 300 gallon. I use it for a system where I have tanks that are 5,000 gallons. The whole idea is I can break each drawback into its inputs and outputs and model them so that when I zoom into the program, I see all my guidance and then I can zoom into it. Because for me it's like port is important. And for me it's like, okay, each drawback has a couple of properties. So it's going in, it's coming out. There's those things. So if I have to do them for 100 things, it's really just a software issue. But I don't know, one, I don't know a lot of big aquaponic commercial farms, and then 2, I spend a lot of my time in my lab. Yes, sir?
Yeah, Eric, I've known you for a while, and you know, I do some work in agriculture and these sorts of things. There are sensors out there that are available, but they tend to be very expensive for large-scale systems that measure things like, you know, temperature, pH of the water, turbidity that has to off when you've got some you know, algae growth or the water's clear. Also what's called EC, which is electrical conductivity, which often has to do with your levels of chemical nutrients in the water and such. And then there's monitoring and control software out there. But all those things are designed for very large systems. They're very expensive. They're very user-unfriendly, difficult to use, and so on. One of the things that Eric is doing is really small-scale, do-it-yourself, maker-based stuff that can really be used in academic settings, home, you know, food production, and so on. So it's really a big sea change in terms of bringing the scale down to something that's much more accessible. Also, the flexibility of the data. Most of those systems that I just mentioned that are commercial and such, you can't really get at the data. You can't modify the software. It's behind IP firewalls. It's not modifiable. You're kind of stuck with it. But with his, you know, if you have some command of the code and stuff, you can really get in and customize it, build your own user interface, and really build something that really works for you. So it's totally flexible and totally open source. It's really great what he's doing. Yeah.
So question, with the grow systems, I had a look at your website. So it seems like you sell some kind of like grow area that the water flows through and it grows stuff. I mean, how many people can you feed off such a device?
First of all, my website is more than 3 years old.
Oh, okay.
Yeah, that. I got kind of selling things and I'm about to get my first, what I showed you, that's my first prototype from China.
Okay.
It's getting a bunch of those, so this sort of changed the game of it's kind of like a living, like buying things off eBay and Amazon. It's okay for hobbyists. But then, so he's talking about a gadget that's it's 4x8. So those are like, he said, I have one in my kitchen right now.
So 4 feet by 8 feet?
I'm sorry, 4 feet by 2 feet.
Okay, yeah.
So my standard is 4x8,
Yep.
and then pretty much I just scale off that. So I can scale my software and pretty much, I don't want to create new problems. I'll just like make the big or small. But then he's talking about a gadget that's 4 feet by 2 feet with a glass tank at the bottom that's about 50 gallons and they're about like 1 foot deep. Are they lighting up one? Did you look at the food blog? I have a food blog of all the food I got from that garden.
No.
Yeah, like got more than 500 types of stuff. I took pictures of actually there. So automation changes a lot of things. Like when it comes to gardening. So when it comes to food, the general model for food is somebody out there knows a lot of food for you. And you go to the store, you buy enough food for 2 weeks and you put it in the fridge.
Yeah.
And you eat it it after 2 weeks, you will get more food. So for me, what technology does is, a long time ago, I used a computer to went home and actually rest time, go to college, but now I have a computer in my pocket. So, for instance, like being able to take pictures a long time ago, take a picture and take it to photo me less within that 1 hour production. Now I don't have to because I have enough technology to actually take a picture and look at it. So technology makes the existence. What I mean with that with food is, if I model my garden and my technology in such a way that they mesh one another, then it means I do not need, I only need food for when I'm hungry. It does not make sense for my garden to grow food I'm going to be eating 2 weeks from today. So I grow things that actually match my software and electronics process. So when I want food on that day, that's when I get it. So when I wake up in the morning and I want like a salad in my omelette, you know what, I go to my garden and I can actually have a salad.
So the water so you grow your vegetables in this thing or whatever, so you put water over it, the water drains through and then it goes into the fish tank?
Yeah.
So the fish, I guess the fish swim amongst this water and then you pump the water out from the fish on top of the vegetables again?
Yeah, what I do is I can touch the bacteria on the system that breaks down the fish oils. And that's it. So it's really a composting system for fish oils.
Okay, so because like I have koi fish at home and the water, I can't imagine ever wanting to drink that water because it's filled with like fish poop and stuff. So
I don't think that's the reason. I think you're more drinking because of that.
Not that first.
okay. Okay, so basically, so the fish and the vegetables are a system, and so how much water do you have to put into the system every week or whatever to refill it? Because I imagine you'd lose water due to evaporation and whatever. So.
Very little. Most of the evaporation for me comes in because of my plants and the leaves and the summers. So the more plants I have, the more evaporation I have.
Yeah.
Generally, what I do is I grow microgreens. I just sprinkle seeds on top. And if I sprinkle seeds today, within 3 days, they'll be here. So pretty much I cut a section and put it in a plate. And I cut my next one and put it in my burrito. Next one I have like, next day I have like in my salad, my sandwich. By the time I get to that side, the side is gone.
I'm saying, but is this method more efficient than regular outdoor agriculture, that it's more conservation?
So I'm trying to give you an example. So using a small 2x4 garden, I can actually get a plate of salad every day. So I don't get a lot of food, I don't need a lot of food because I'm not going to food through it in the fridge. But I was able to do that for 500 meals, which means pretty much every day I got a plate of microgreens.
From half a liter of water, you said? Did you say 500 mils of water?
500 meals.
Oh, meals. Sorry. No, I'm saying how much water do you have to put into the system every day to like?
Very little, that's what affects it, almost nothing. So like,
Okay.
because whatever the plants don't take, pretty much it gets recycled.
Yeah.
See, if you put water in a pot, most of it goes at the bottom.
Yeah.
But
So
we don't know how much water you use, how much energy you use, how much mass you feed to the fish, or how much the fish food costs. So it's kind of hard to compare to other
because,
systems.
for instance, I have a power meter built into the thing. So I can easily tell how much power I'm using.
Yeah.
Okay. I use LED lighting. My pump runs like a minute or two every hour. All day going on. My system, I put like a Home Depot bucket of water in my reservoir system. I don't have that for 3 weeks.
So if you really felt like you could almost power it, like from electricity point of view, I imagine it would be very low.
It's a good power supply.
Yeah.
See, if you're using just very low wattage, you need the battery backup. But
Yeah.
that's-
It's basically the fish food and the water, and that's the only thing that you put in.
Fish food, I've raised roaches, I've raised maggots, I've raised worms. Half my fish are pretty much eating my leftovers.
Yeah.
Honestly, I'm about to start raising piranhas because people are always putting their fingers in my tongue. So it's also, I just think it just depends on what you're trying to do. If I'm trying to make a business, I'm trying to optimize those things to make a saving.
Oh, I think it's incredibly interesting.
See what I mean?
But I would just stop short of actually comparing your efficiency to a larger scale system because you're not comparing apples and oranges. So you can't actually say this is more efficient
I
than
know.
other systems.
Well, yeah, but on the flip side, though,
Solar on the roof.
I'm back to what do you mean by efficient? What's the definition of
Well,
efficiency?
yield per square foot is one common indicator, and I'm an ag extension agent, and I work with a lot of this stuff. Yeah, it's a number of times higher yield per square foot than even highly intensive bed outdoors do. And he's not even trying to be commercial, really. He's doing studies, education, and such. He's not trying to optimize it for yield.
I'm more interested in getting food or not food.
The other thing though is
So
that
that's more important than having a lot of food that I can't even make a profit. Sure. So here's the thing. I can give you like a good example. Like if you grew like a salad outside, I think outside is the best place because I don't think you can grow anything as big as a regular tree. So I'll start it by I'm mimicking nature. So everything I'm trying to do for me is not about plastics, it's not about pieces of wood, it's not about that. It's like I'm trying to copy off a model that works all the time. That's gonna make things really easy for me. So if I do the same thing outside, I do the same thing using smart aquaponics. Custom growing outside might grow better stuff, might even grow much better yield. But the process of them harvesting that has first of all like more food insecurity than mine. Just so there's things like that. And then two, they might harvest all that food and actually get really good food. My garden with smart aquaponics might not harvest that much, but guess what? I have tweeters where I can send customers, and I can send them all these feeds before I even put my seed in, so they can start looking at my plant as they're growing. So if I was a restaurant and I have food growing somewhere that's automatic, it means I can actually start selling my food before it even grows. Because most people can only sell their food after it grows. Because the restaurant has to provide food and how people are going to come. But using technology, I can actually change that process around. It's more than just the growing things. There's all these other things it addresses on different levels. I can make it so that, hey, see what, yeah.
Oh, no, go ahead.
But you see what I mean?
Yeah.
So I just feel like it's more than, am I growing more food than that?
But the thing with commercial agriculture is they hide a lot of their efficiencies are hidden in the fact that they use tons of chemicals and that their water is almost free. See, his system doesn't use much water, so their stuff might appear cheap, but it actually has a higher society cost than what we're aware of, like the trucks that needed to bring the food to the supermarket.
There's all kinds of external costs here, and then there's
Yeah.
subsidies as well.
Yeah, but that's what I love about this is once you've got this thing set up, you're pretty much getting it for free and you pedal your bicycle once a day to power it.
What is the scale? Like, are we talking, it works just as well with, you know, your 1 gallon fish tanks as with your 300 gallon fish tank, 5,000?
Yeah.
So is it equal yield across all sizes, or does it actually get bigger? I mean, I imagine if you get to the size of the planet, you've got a fully sustainable system that's for a living. But
So I look at it as whatever problems you get with the small one, pretty much.
yeah,
Still the same way. Whatever advantages you have with the small one, then you amplify the same way.
so if I went home and bought a fish tank and just started this whole process, I would see the same issues with, you know, the small tank, and kind of work my way up until I basically got my whole backyard.
What you're talking about is, you're talking about the mechanical fixes. For me, what I've been trying to do is like, can I get the same biological life? Can I get a system that's going to have the same biological efficiency as mine? So the way I design everything, these gardens are not, you can buy as much fish as you want, you can buy as many plants as you want, you can't buy that in your life. So the whole idea behind that good design is really pretty much, it's bacterial farming. So it's about like, I can have the same garden as you. I mean, there's all sorts of things that go into a good design. And then there's something else about these gardens. Until you get to the point where you have like nice biological mass in terms of bacteria, your garden has nothing growing. Pretty much everything you're growing dies. So you're talking for at least a month if you have a well-designed garden before you can even see it becoming efficient, because you can put as many plants as you want, you can put as many. It's the bacterial life, it's the things at the bottom of the ocean that stabilizes everything. So it's not about the plastics, it's not about your farm. If you can get your bacterial life correct and keep building the life, because as the gardens grow, take long and actually become more and more efficient. So the same efficiency I get from my garden today is going to be very different from the efficiency I get from my garden 1 year from today. Because I have more nature on it.
Yeah.
So, yes, sir.
Have you heard of a company called City Blooms?
No?
So City Blooms has hydroponic systems. They call themselves urban farming. And so I work at Plantronics. And it so happens that City Blooms is right around the block. And we're the first customer. So they've set up about I'd say about 8 to 10 4x8 units, very similar to what you're fully enclosed, but very similar all sensor-based database. And they're supplying right now about 60% of our produce for about 800 employees at Plantronics. So it's pretty interesting stuff, which is why I wanted to combine and see this. So I think it would be good for me to introduce you to those guys.
What's their website?
It's called cityblooms.org. I just checked a moment ago, though. It looked like it was coming up.
.com was down, but
Yeah, the .com is
Do they use fish?
They don't use fish, no.
Well, I just feel like when it comes to that stuff and start doing money, it's got to do with more like how good you are as a business. Because I feel like, I don't know, my system might not be efficient, but I can make good money. For instance, I can grow my wine. Now the better grow, like I can get like, you know what I mean? I may not be the best farmer. I've been like up to the mountains, up to the farmers up in Nevada now. Just to be a farming community.
Predictable.
Nobody, even families with kids and everybody, nobody farms anything else. The whole time they think like one crop of a summer because they might have all these efficient systems that have water and everything, but you know what? They found an efficient crop. They just grow a little bit and get free for the rest of the year. You know, you might have the best system in the whole world with your growing lettuce. Your lettuce might be really, really good, but is your system more efficient? This other person growing like, getting like 5,000 bucks out of like 4x4, and you're getting like, how much is the pound of something?
I don't know. About 90?
About 90,
I don't know.
So how much space do you think you need to grow that? Pound of something?
I don't know.
How long does it take to grow a pound of something? How much resources
I
going to
don't
grow a
know.
pound of
Yeah,
something?
and time. Yeah, and planting. Sure.
So that's
It's
the
huge.
point. I don't want to get tied to what's more efficient.
Well,
So I
you
don't